Conditional probability. The probability that event B occurs given that event A occurs is called a conditional probability. It is denoted P parenthesis B line A close parenthesis, which is read the probability of B given A. We call A the given event. Conditional probability rule. If A and B are any two events with the probability of A greater than 0, then the probability of B given A equals the probability of A and B divided by the probability of A. To look at this visually, we have a rectangle for our universe. Then we have circle A and circle B, and they intersect. With conditional probability, the sample size goes from our total frequency to just the frequency of A. Then our numerator is the number of outcomes that A and B share. Example: find the probability that the adult selected is married. In a statistical magazine, the marital status of U.S. adults by gender is shown in the table below. For gender, we have male, or S1, and female, which is S2. Marital status, we have single, M1, married, M2, widowed, M3, divorce, M4. The probability that we have a single male is 0.147. A married male is 0.281. A widowed male is 0.013. A divorced male is 0.004, which totals 0.485, which is the probability a male is selected. For a single female, we have 0.121, married female 0.284, widowed female 0.050, divorced female 0.060, for a total of 0.515, which is the probability we select a female. While male and female make up the rows, the columns are made up by the marital status. The total for single is 0.268. The total for married is 0.565. The total for widowed is 0.063. The total for divorced is 0.104. If we added the probability for single, married, widowed, and divorced, it equals 1. If we add up the probability of male and female, that also equals 1. So now we're ready to answer our question. We want to find the probability that the adult selected is married. So the probability that the person selected is married, you have P parentheses married, is the total probability for the column married, which is 0.565. Continuing with our example, we want to find the probability that the adult selected is male. We start with P parentheses male, and we look at our total for the row male, which is 0.485. Continuing with our example, we now want to find the probability that the adult selected is female, given that the adult is divorced. So we want to start with our probability female line divorced, which is the correct notation for female given divorced. So we want the probability that we have female and divorced divided by the probability of divorced. Since divorced was mentioned after the word given, that's our new denominator. Looking at our table, the probability female and divorced is 0.060. The probability the person is divorced is 0.104. So the setup is 0.060 divided by 0.104. which is 0.577. Continuing with our example, find the probability that the adult selected is married given that the adult is male. We start with our notation, the probability married given male, which means we have the probability male and married divided by the probability of male. Male and married has a probability of 0.281. Male is mentioned after given, so we want the total for the probability male, which is 0.485. Our setup is 0.281 divided by 0.485, which gives us 0.579. In this example, we want to find the probability that a person chosen is a light smoker, round to 3 decimal places. The table below describes the smoking habits of a group of asthma sufferers. One of the 1,016 subjects is randomly selected. Our rows for this table are men and women. The columns are non-smoker, light smoker, and heavy smoker. We have 394 non-smoking men, 316 non-smoking women, for a total of 710 non-smokers. We have 75 light smoking men, 90 light smoking women, for a total of 165 light smokers. We have 81 heavy smoking men. We have 60 heavy smoking women, for a total of 141 heavy smokers. 710 plus 165 plus 141 gives us 1,016. If we add the row for men, 394 plus 75 plus 81, we have 550. If we add the row for women, 316 plus 90 plus 60 gives us 466, for a total of 1,016. Now to answer our question, we want to find the probability we have a light smoker. The total for light smokers is 165. The total for our sample space is 1,016. So our setup is 165 divided by 1,016, which gives us a probability of 0.162. Continuing with our example, we want to find the probability that the person chosen is a non-smoker, given that the person is a woman. First we write probability non-smoker given woman. The number of non-smoking women is 316. Since we're looking for a non-smoker given that the person is a woman, our new total is 466, which is the total of women in the study. So the setup for our problem is 316 divided by 466, which gives us a probability of 0.678. Continuing with the example, we now want to find the probability that the person chosen is a woman given that the person is a light smoker. We begin with our probability of the event, probability woman given light smoker. We want to find the number of women that are light smokers, which is 90, and this time our new sample size is 165, the total of light smokers. So our setup is 90 divided by 165, which gives us a probability of 0.545. To recap the section, conditional probability, we have the conditional probability rule, which says if we have the probability of B given A, that's the probability of A and B divided by the probability of A. Conditional probability is the only probability where our denominator is not the original sample size.